Good afternoon, everyone. My name is Jeff Brown, and I work for Pivotal. Pivotal is the organization behind Groovy and Grails and a whole bunch of other technologies, but I'm going to be talking pretty much about Grails in particular today. My email address is jbrown@gopivotal.com. You can find me on Twitter at JeffScottBrown. If you have any questions at all that I can help you with after we're done today, please let me know. And I'm happy to help you with anything that I can. So just to get started, a quick show of hands. How many of you have done anything at all with Grails? Yeah, a few. Very good. So I'm going to provide just a little bit of history about the framework and a little bit of overview, and then we're going to jump quickly into an application and play with some source code. Normally this is a 90-minute session, and the difference between 60 and 90 minutes is maybe more than you might think. In a 90-minute session, normally we can build this whole application that I'm going to talk about from scratch, and it's really tough to do in 60 minutes. So instead of building the whole thing from scratch, I've got a good bit of code written, and we'll just pop that up and look at it and make some small changes to it. So I think we should be in good shape to get through all of this in 60 minutes. So let's get started. So Grails is a full stack framework for building web applications for the JVM, in particular for the JVM. If you're targeting any other platform, Grails is not going to help you with that. Grails leverages a whole bunch of existing technologies to make up that full stack. So inside of Grails is an ORM tool, and inside of Grails is a runtime environment, a servlet container for you to deploy your application. Inside of Grails is a dependency injection container, a logging framework, all that stuff that makes up a build tool, all that stuff that makes up the full stack framework. Most of that, or at least much of that, is implemented by some other tool, right? We didn't write our own dependency injection container for Grails. We used Spring for doing dependency injection. And we didn't write really a full ORM tool from the beginning. We built the thing on top of Hibernate, and we didn't write our own build tool. We took advantage of a technology called Gantt. So Grails is really made up, it's this full stack framework that is made up of a bunch of best of breed technologies for solving those kinds of problems, right? The kinds of problems that show up in lots of web applications. So we'll talk a little bit more about some of those details in just a bit. Grails features a plugin system that's a really important part of the whole Grails story. If you're going to do Grails application development, the plugin system is an important part of that process. You're going to want to take advantage of a lot of plugins that are out there. You may end up writing some of your own plugins, and a lot of the cool stuff that we're going to look at today in this little kind of simple Twitter clone that we're going to dig into. A lot of the cool stuff in that application has to do with behavior and functionality provided by plugins. So just note that the plugin system is a really important part of the Grails framework, and I'm going to talk more about that when we start looking at some code. So this is a list of some of the big players in that list of best of breed technologies that I mentioned just a while ago, right? So Groovy is this really powerful dynamic programming language for the JVM, and Grails uses Groovy all over the place. Right? We use Groovy for lots and lots of things. Of course, Java is part of the story here. All of this is built on top of the JVM. We use Spring for dependency injection and transaction management, and we use Spring for a lot of things. Spring is really a core piece of the Grails framework. Grails is built on top of Spring. We bundle a version of Tomcat with Grails, so when you install Grails, you've got a version of Tomcat there. You wouldn't use that particular copy to deploy your production applications, but in your development environment, there's a simple command. You type Grails space run app, and what that does is it fires up an instance of Tomcat. You don't have to know anything at all about Tomcat. You don't even have to know that it is Tomcat, but that's what's there. You type Grails run app, and Tomcat is started up, your application is built and deployed to that Tomcat, and you can start interacting with it in the browser, and we'll do some of that in just a bit. But that's bundled with a framework. That's not something you have to configure on your own before you can take advantage of that. Grails includes this ORM layer called GORM, G-O-R-M. ORM is really a tough problem to solve. So the framework doesn't provide a full ORM solution. what the framework provides is a really, really powerful and flexible and expressive layer called GORM on top of some other persistence engine. And initially, we built this on top of Hibernate, right? Hibernate is a really powerful, really flexible, and really popular ORM tool for the JVM. If you're writing Java applications that talk to a relational database, there's a pretty good chance that you're using Hibernate to do that, right? Hibernate is, for a long time, has been kind of the de facto standard ORM tool for the JVM. So we built GORM on top of Hibernate, and then later on, something that happened is we really fully decoupled GORM from Hibernate. And with recent versions of Grails, and it's been this way for quite a while now, you can pull Hibernate out and plug in some other persistence engine. So we've got, there are a whole bunch of GORM plugins. There's the Hibernate plugin that we provide. There's a MongoDB plugin. There's a Cassandra plugin. And if you invent a new data store this weekend and want to write a GORM implementation of that, you could do that, right? So we're set up now where we've got GORM, which is this ORM abstraction layer provided by the framework, and it's pluggable, so you can plug in lots of different persistence engines underneath the GORM layer. Generally, when you're writing persistence code in your Grails application, you're not writing Hibernate, for example. Hibernate is the default persistence engine, but you're not writing Hibernate code, you're writing GORM code. And Grails, the Hibernate plugin that you would be using by default, converts all that GORM code into all the tedious Hibernate bits. So Hibernate is used to talk to the database. But generally, your application code is GORM code, not Hibernate code. You can poke down a layer below and get into the Hibernate stuff directly if you like. If you wanted to interact with the session factory, for example, there's a really, really simple way to do that. But for the most part, you don't have to do that. You end up writing just GORM code. And one of the nice things about that is then you can pull Hibernate out and replace it with MongoDB, if that makes sense for your application. And for the most part, your application code stays exactly the same because you weren't writing Hibernate code, you were writing GORM code. And GORM, there's an implementation for GORM that knows how to talk to MongoDB, for example. So we'll look at some of that when we dig into the application source code. Site mesh is another piece of technology here. We use site mesh for page layout and page decoration. The idea here is that Grails is this full stack framework, and it leverages a whole bunch of other technologies to make that address these common problems that show up in lots and lots of web applications. So this is kind of a visual representation of how all of this is laid out. All of this is built on top of the JVM. Right, and that layer of technology there where you see site mesh and Spring and Hibernate, there's a bunch of other things there. There are those three and Log4j, and there are a whole bunch of technologies that Grails builds on top of. So Grails is built on top of all that stuff, and Groovy is kind of a thread that we use to tie all of that together, right? So when you build a Grails application, you're probably going to be taking advantage of Spring, and you're probably, at least by default, going to be taking advantage of Hibernate. But you never have to write any Spring code, and you never have to write any Hibernate code. You can when that makes sense, but you can get an awfully long way down the road of taking advantage of those technologies without having to interact with them directly. Grails kind of manages a lot of that for you. Right? This is a small subset of a lot of the kind of big name companies that have been using Grails for a long time. Netflix, LinkedIn. You can see the list there. So there are lots and lots of big serious enterprises out there that have been using the framework for really for a long time now. I mentioned before that the plugin system is a really important part of the whole Grails story, and this graph is a couple of years old, but the point is correct. So in 2008, there were about 150 plugins in our public plugin portal, and then in 2011, there were something like 600. And if we looked at the portal today, we'd say there's something like 900, right? So there are 900 and something plugins in our portal, and there are plugins to do all kinds of stuff that shows up in lots of web applications. So for example, if you're building a Grails application and you want your Grails application to use CAPTCHAs, there's no reason for you to have to write all that and solve that problem yourself. There are several CAPTCHA plugins out in our repositories. You can install one of those plugins and then take advantage of it, and you end up not having to solve the CAPTCHA thing yourself, right? You're using a plugin that solved that problem for you, and now you get to spend more of your time and more of your effort solving your business problem and not solving these common web application problems. So there are CAPTCHA plugins, there are security plugins, and there are caching plugins. There are plugins for all of these problems that show up in lots of web applications, and you want to take advantage of those. Like I said, this graph is out of date. If we extended this out to 2013, we'd see that the trend has basically continued. There are over 900 plugins in the portal right now. So before we press on and get in code, any comments or questions about the framework at a high level at this point? No thoughts? All right, very good. Let's get to the fun bits. So I'm going to jump into the IDE here, and like I said, instead of starting completely from scratch, we've got some code in place that we're going to use as a starting point. The first thing I want to do is just start the application up and interact with it so we can get a sense for what the application does right now, and then we'll back away from that and look at some of the source code and get a sense for what it takes to do some of these things in a Grails application. So what we've built is a really simple and trivial kind of Twitter clone. So we'll see that I'm going to be able to, once the container's up and running, and it is up and running right now, so we can open a browser and send requests to this URL, and we have a pretty lightweight, simple Twitter clone here. I don't want to do this in the IDE. I'm going to go open a real browser and do it out here. All right, so we're interacting with the Grails application right now. So like I said, what we're going to do is step through some functionality in the app really quickly, and then we'll back up and look at the technical details of how some of this happened. All right, so the system supports authentication, and it turns out it did that with very, very little code. We'll see what it took to make this the security part of this happen, but there's very, very little code in our application that relates to authentication. So I'm going to log in as Jeff. Like it says there, my password is password. If you try to log into my real Twitter account, my password is not password. That will not work. All right, so here is our Twitter interface. It's the first time I've logged in, so there's no data. We don't see anything interesting. So I'm going to update my Twitter status. I'm going to say that I am at JaxConf, right? And click Update Status. So here's my first Twitter post, is I'm at JaxConf. I'm still at JaxConf, right? There's another post on my Twitter timeline. So I can keep posting messages, and they'll show up in my timeline here. And I'm not going to go through the process of doing this, but if we entered more than 10, we're only going to see the most recent 10 there. We'll look at the code, the relevant code for that in just a bit. All right, so Jeff is logged in. He's posted some messages to his Twitter account, and that's the state that the system is in. So I'm going to log out and log back in as someone else. I'll log in as Graham. And we see his timeline is empty. There's nothing down at the bottom there. I'll type Graham's first post. All right, so now his timeline is being populated. He's got one thing in his timeline. And we'll log back out and log back in as me. And my timeline is in the same state it was in before, right? We see I'm at JaxConf. I'm still at JaxConf. All right, so that's all the interacting with the application we need to do for now. So let's just review what we can do. So we can log in as a user. I can post some messages as that user. I can log out, and then I can repeat the process. I can log in as a different user and post some. So all those statuses are stored in a database right now. One thing we can't do is follow other people, right? There's nothing in the application to support that yet. We're going to add that. It'll be really, really simple. But we can't do that. So really all I can do with the application at this point is post messages and view my own messages. That's all I can do. So it's not terribly interesting so far. All right, notice down at the bottom, that list of status messages there, you see several details. You see Jeff Brown said something, and then you see a date, right? So there's three pieces of information there. There's a person, that's whoever posted the message. There's the message, and a date and time that message was posted. Let's go look at some source code and start talking about some Grails features that relate to all of that. So in my Grails application, I've got a domain class. And a domain class is a special kind of artifact that Grails treats domain classes differently than other classes. One of the things that Grails does with all of your domain classes is it maps them to the database, right? So this class has been mapped to the relational database that our application is using. This is the entire source code right here. So I've defined a class called status. A status has three properties. It has a message, it has an author, and it has a date created, right? When it was created. The message is just a string, right? It's whatever you typed in the user interface. The author is of type person. We're going to look at that class in just a second, so stand by on that. And date created is java.util.date. All right, so every status has 3 properties. Those 3 properties correspond to stuff that's being displayed at the bottom of the page over there. And this is the source code for that domain class. So this is a Groovy class. It's in a file called status.groovy. That's all valid Groovy code. I don't need semicolons. All that code is perfectly valid. Let's look at the code that gets executed when I type something in here that says, this is my latest update, and click Update Status. I want to look at the code behind that button. What happens when I click Update Status? So from the user's perspective, what's happening is a new status message is being created, and my timeline down at the bottom is automatically updated with that information. So every time I fill out that form and click Update Status, one of these things is being created and persisted to the database. All right, so let's look at the code that makes that happen. So we've got a controller called Status Controller, and it's the only it's the only relevant controller that we need to talk about right now. And inside of the status controller is this action right here called Update Status. And that code is being executed. So lines 20 through 24 there. That code is being executed each time I fill out the form and click Submit. So this is the code that we want to evaluate. Really, the interesting part of this at this point is line 20. So that says status service.update status, and we're passing a message as an argument. The message that's passed into our controller action here is whatever the user has typed into the form. So if we go back to the browser and view the source on this page, what we'll see is that there is a form, an input field right here. That's not the right one. This one down here. There's a text area whose name is message, right? Text area, name equals message, ID equals message is what that says. So the name of that text area is message. When this form gets submitted, Grails will do some interesting things with the request parameters on your behalf. So the form is submitting to this controller action right here, the update status controller action, and there's a parameter. We've declared a parameter called message. And what Grails will do with that is it will look at the variable name, message, and when this controller action gets invoked, Grails will look to see if there's a request parameter with that name, and if there is, the value of that request parameter is passed in here. So we don't see any code here that's dealing with request parameters or servlet stuff or any of that. Grails is managing all of that for us. All we had to do was to declare a parameter called message. And if I wanted other pieces of data to be passed in here, as an int number of something, right? So with that, if there was a request parameter called number of something, Grails will automatically pass the value of that request parameter into this controller action. So you don't have to write anything that interacts with the request parameters directly. You can, but you don't have to, right? If the only reason you're interacting with the request parameters is to go grab particular values, you can eliminate that and let the framework pass the values into your controller action for you. Another way you could do this is you could say message equals params dot message, right? We could get rid of this. Now Grails is not going to pass anything into our controller action. The controller action doesn't accept any arguments. But now we've got this code that's explicitly or directly interacting with the params object, right? Params is a map that includes all the request parameters, so now I'm interacting with that thing directly. That's not terrible, but we can eliminate that by letting the framework know what pieces of information we need, and we express that in the form of arguments to the controller action, right? Questions about that? Is that good? All right. All right, so whatever the user typed into the form field is being passed into the update status action here, and line 20 is really the interesting bit that we're going to focus on, and that is, so it's invoking a method called update status on status service. So let's take a look at what status service is. On line 10 there, we've got a property named status service declared in this controller, and if we scrolled around all over this controller, you would see that there is no code anyplace that initializes status service. So it looks like status service should be null, right? But it turns out that Grails is going to initialize that for us. I briefly mentioned, we talked a little bit about this status domain class earlier. Grails does special things with domain classes, right? It maps them to the relational database and adds a bunch of special methods to them that we'll talk about some of those in just a bit. But a domain class is a special kind of artifact to the framework. There are other kinds of special artifacts that mean different things to the framework, and one of them is our service classes. So if we look out here under services in our application, I've got a couple of services already created. One of them is called status service. That's the source code we're looking at now. We're going to talk about all this top part in just a bit. But inside of this status service class is a method called update status. Nowhere in our application is there any code that creates an instance of this class. So as the application developer, we created this class, called it status service, and put it in a particular place in the directory structure, and that told the framework that this is a special class. This is a service class. So a service class means something special to the framework. One of the things that will happen to this class automatically, without you having to write any code, is Grails will create an instance of this class and put it into the Spring application context, and the bean name in the Spring application context will be the class name lowercased, right? So the bean name is going to be status service with a lowercase s up front. So in the application, in the Spring application context, there will automatically be an instance of this class. You don't do anything to make that happen. Grails will do that for you. And then in addition to that, all Grails artifacts are automatically subjected to dependency injection by name. One of the consequences of that is if I declare a property in a controller, for example, called status service, like we've got on line 10 there, if there's a bean in the application context with that name, Grails will do the dependency injection for us. So we don't have any code that creates a status service. We don't have any code that initializes this reference declared on line 10. But before our application code gets executed, all that stuff has happened, right? A status service object has been created. It's been put in the context. It's been injected into this controller, and the controller can directly interact with it, right? So down here on line 20, the controller is invoking this update status method on a thing that we never initialized, but the framework initialized it for us, right? Does it make sense? Right? All right, so what we're doing there on line 20 is invoking update status on that object and passing message as an argument. Remember that message is the string that the user typed into the form there. So let's look at that update status method. So line 26 is creating a new status object. Remember, status is this thing we looked at over here, right? A status has a message, an author, and a date created. Message, author, and date created. The service is creating one of those on line 26 and initializing the message property. Only the message property is being initialized on line 26. So the other two properties are uninitialized so far, and that is the date created is not initialized, and the author, the person who posted this message, has not been initialized. The author is initialized on the next line, right? Line 26 says status.author equals lookup current person, and lookup current person is retrieving some information from the security plugin to figure out who's logged in. I don't want to get distracted with that bit right now. What I want to notice is that by the time the thing is saved to the database, when line 28 executes, status, the message of the status has been initialized and the author has been initialized, but the date created has not been initialized. Right? We don't see any code here that's assigning a value to date created. So we might want to do something like this. We might say status.dateCreated equals new date, right? We want it to be right now, right? That's what time the message was posted. But we don't need that. We don't need that code. It turns out that date created is a special property name that means something to GORM. So when GORM objects are persisted to the database, if there's a property in the domain class called date created and its type is a date, GORM automatically initializes that thing. And that's a common thing, right? Often you have a timestamp or a date associated with an object, and you want that to automatically be initialized with a value that represents whatever time that object was created. So instead of every Grails application that wants that behavior having to repeat that logic over and over and over again, the ORM tool solves that for you, right? So if you declare a property in a domain class called dateCreated, it will automatically be initialized. You'll never need to, in fact you shouldn't, ever initialize that property. The ORM tool will initialize that property for you. Right? So our status service, update status method creates a status object, initializes the message, initializes the author, and saves the status object. So when line 28 executes, that object is persisted to the database. Right? So we're invoking the save method on the status object. The status object is an instance of the status class. If we go look at the status class, there is no save method here. Right? There's no, if there were a save method, it might look something like this, right? Save, and then some code in here to talk to the database. But we didn't have to write that code. That code exists, but we didn't have to write it. One of the things that Grails does to all domain classes is it adds a method to every one of them called save. And the save method does whatever it takes to persist that object to the database. So if we're using Hibernate, the save method will do one thing, and if we're using Mongo, the save method will do another thing, and if we're using Cassandra, the save method will do a different thing. But all this code, all of our application code stays exactly the same. So we pull out the Hibernate plugin and push in the MongoDB plugin, and all of this still works. Right? We don't have Hibernate queries to address. We don't. The ORM abstraction layer is managing all of that for us. Right? Make sense? Questions or comments about any of that? Yes, sir. Yeah, so how do you express that a class is a domain class as opposed to a service or some other artifact type? It's a good question. So in your Grails application, let's take a look at what the file system looks like for our Grails app. Right out here. There we go. Grails Twitter is the one we're after. On the file system is a directory called Grails-app. And below Grails-app are some folders like controllers and domain and services and taglib. Those directories, they have to have those names. Those are names that mean something to the framework. They're automatically created when you create a Grails application. And so all over the place, Grails leverages this really powerful idea of convention over configuration. Convention over configuration. If you follow a convention, that takes the place of what would otherwise be a configuration burden. So typically when you write a Java application, say that's going to use Hibernate, you've got to configure Hibernate to know about your domain classes. You have to tell it about all of your entities, right? Is what Hibernate refers to them as. So you don't want to map every class in the JVM to the database. That's crazy. That wouldn't work. You don't want to do that, right? You want to map a subset of your classes to the database, and you have to tell Hibernate about that. And one way to do that is to write Hibernate XML files and use their syntax and do all of that. Another way to do that is to annotate your classes with that entity and do that thing. But somehow you have to tell Hibernate about which of your classes should be mapped to the database. The same is true inside of Grails, but the technique is different, right? The way you express that something is a domain class in Grails is you declare it under this domain directory, right? So at the top of your project is a folder called Grails-app/domain. And if you declare a class under that directory, it's a domain class. That's it. There's no configuration file, there's no annotations, there's no XML. If you declare a class under the domain directory, it's a domain class. So that class will have a save method added to it. That class will, everything that Grails does to domain classes, it will do to every single class under the domain directory. So the way that you express that a class is a domain class is you declare it under the domain directory. And similar rules apply to all the other artifact types, right? So our status service is declared under this Grails app services directory, and the class name ends in service. So if you declare a class under Grails app services and the class name ends in service, it's a service. And there's a whole bunch of special stuff that happens to services. Right? The question was, is it possible to override the save? Is that what you said? It is possible. So Groovy makes it, Groovy is a dynamic programming language, and that means a lot of things. One of the things you can do with dynamic languages like Groovy that you cannot do with statically typed languages like Java is you can add methods to classes at runtime, and you can change the behavior of classes at runtime. And it's really a pretty simple thing to do. It turns out that you can replace the save method if you want, but there are good reasons not to do that for a method like save in particular. If your application is using plugins that are relying on a certain behavior of that save method, you might be complicating things there. So the bottom line is if you wanted to replace the save method, you could, but you probably don't want to do that. Whatever it is that you're going to do in your version of the save method, you should probably call it something else, like save fast or save slow or whatever. You can add a new method that's not save. It's called something else, and your method does whatever you like, and then the official or the original save method is there, and you're just not using it. So you can replace the save method, but you probably don't want to do that. All right, so our service class here creates an instance of the class, populates its properties, saves the thing to the database, and all of that stuff that I just described happens, right? Date created is automatically initialized with right now. So when we look back at my timeline, we see that each of those things has a timestamp associated with them. The first one was created at 5:16, 5:16, 5:19, so forth. All right, let's add a piece of functionality to our application. So I am going to Grails Twitter, what do we got here? We want to, yeah, so let me look at, let's take a look at that person class. Remember that a status has a property of type person, right? So every status has a message, a date created, and an author. The author is of type person. Here is our person class, and the person class has a number of properties in it. It has a real name, like Jeff Brown, has a username, like J Brown, has a password that is whatever my password is, and then some Boolean attributes that control whether this account is enabled or locked or expired or whatever. All of that is, this was generated for us by a security plugin that I installed into the application before we started today. So I don't want to get too far down the security path, but this class represents a user that can authenticate into the system. So when I fill out the login form and I type in Jeff and put in my password, the system is looking in the database for an instance of this class that matches the username and password that I entered. All right, so a person has a real name, a username, a password, and some other attributes. Line 12 is what I want to talk about right now. So has many, and the person class is a domain class, right? The users are persisted in the database. So line 12 declares a property called has many, and the value assigned to that has many is a map, right? So Groovy has a literal syntax for defining maps, and the way that works is you can say, so like map, some map equals name JSB, town, I live in St. Louis, zip is, right? So the way the syntax for maps work in Groovy is inside of square brackets, you can have these comma-separated list of key value pairs. So that's a key value pair, right? The key is name and the value is JSB. The key is town and the value is STL, right? So the map that's declared on line 12 has just one entry in it. The key is the word followed. That could be anything. We just called it followed. And the value is a type. It's a class, right? So what we're expressing there, really a whole bunch of stuff happens because of line 12, right? Has many means something special to GORM. If you declare a has many property in a domain class and initialize it with a map like this, a bunch of special stuff's going to happen. One of the things that's going to happen is GORM will add a property to this class with this name, right? Followed, the key in the map. And that property will be a set, and it will be a set of those things, right? The thing that's the value in the map that's associated with followed. So I could add another thing here. I could say, let's say we had a city domain class. So I could add another entry to this map, and now a person has a followed collection and a person has a towns collection, and the towns collection would basically be this. Right, so you can put as many entries in that map as you like. So we're going to go back to what we started with, which was just one entry in the map. So what that entry is about is every person, we want people to be able to follow other people in Twitter, right? So in the database, we somehow need to model all of that. So we've already got stuff in place to persist person objects, and we want to associate them with each other somehow. And that's what this followed property is about. So every person has a set called followed, and we can populate that with other person objects. So when Jeff posts some messages and Graham posts some messages, if Jeff is following Graham, I want to see Graham's messages in the timeline. Right? Does that make sense? So we don't need to declare line 14. That happens, line 14 happens because of line 12. So the has many causes that property to be added to this class. All right, in our application, there's a form for searching for other users up here at the top, right? And if I type in Graham here and click search for you, well, I stop the application. But what would happen if I started the application back up, when I fill out that form, I should see a list of all the person objects that match the criteria that I entered. And to make that happen, I'm going to add just one line of code to the person class, and that is this line. So I've added line 13. Line 13 says static searchable equals, and then there's some data there that describes, provides some details for how I want to be able to search for person objects. So I only want to be able to search for real name. So if I send a request into the search engine, that we'll talk a little bit about in more detail in just a second, but if I send a request into the search engine that says find me all the records that match Jeff, what I'm expressing on line 13 there is I only want to search the real name property. That's this property right now. So if someone's password is Jeff, I don't want to match that. And if their username happens to be Jeff, we're not going to match that. We only want to search for, across the real name column in the database, if you will. So let's get our application back up and running. And that's all the code in the whole application. There's no other code related to searching that I had in place before. The only code that we're going to have to provide related to searching is line 13. And we get some really sophisticated, really powerful search capabilities. And we'll talk about where that's coming from in just a second. All right, so our application's back up and running. We'll go here to our status controller, and I'll log in as Jeff. Password. Jeff1, Jeff2, right? So I've got a couple of statuses, posted there. I've got Jeff1, blank when I click submit twice, and then I've got Jeff2. If I go up here in the search box and type Graham and click enter, we get, it's a lame user interface, right? But I get a list of all the people in the database that match that search criteria. And there's only one, right? So if there were a whole bunch of Grahams, we'd see a list that included all of them. This is a list of all the records in the database that match that search criteria. And whatever complexity is involved in executing that search, there's complicated indexing and all kinds of crazy performance stuff going on. I didn't have to write any of that. All I had to do is express that the real name property of person objects are searchable, right? And the way I did that was with line 13. In my Grails application, under the conf folder, there'll be a file called build config, and this is where you configure some of the things about your build. One of the things that I've expressed in my build config is that this project has a compile time dependency on version 0.6.3 of a plugin called Searchable. Right? And we see there are a number of other plugins that we're using there as well. The Searchable plugin is the plugin that's providing all of the search capability. Right? The Searchable plugin will look through all of your domain classes and try to find this searchable property. And if the searchable property is there, the Searchable plugin will take that domain class and configure it with all the complicated search capability provided by the Searchable plugin. So there's nothing in the core of Grails that does search for you. There's nothing in our application code here, in the Twitter application code, that does searching. So what we did was installed the Searchable plugin and expressed some metadata about what I want to be indexed by the search engine, and now I get search capabilities in my application. Yes? So I think the question was, so when I execute a search, am I searching for all real name properties? So right now, the person class has a real name property. What if there was a real name property in some other class? Would we be searching those columns as well? Is that the question? Yeah, so let's take a look at that. So when you execute a search, how do we know how would you know what is actually going to be searched? If we look at the controller action, well, let's take a look at the view that generates this page. That'll help us get there. So let's go look at Grails app / views. I'm not seeing that. Here we go. Grails app / views / status. index. All right, back to the browser for just a minute. I want to go back and look at this page. So the page that initiates the search this is the page that initiates the search. And there are two forms on this page. This form up top that allows you to execute searches, and there's another form down here that allows you to update your statuses. All right, so we want to look at that top form, and this is that form. So this form, if you look at line 10 there, it says g:form controller equals searchable, name equals user search form. This is when this form is submitted, the form is going to submit to a controller called searchable. And we don't have a searchable controller in our application. The only controller in our application is the status controller. But the searchable plugin provides a searchable controller. So when we fill out this form and click search, we're executing code provided by the plugin. We don't have a searchable controller, but there's a searchable controller provided by the plugin. And that controller allows you to specify information like what are your query parameters? And the way to specify your query parameters is to send in a request parameter called Q. And it turns out that our text field has a parameter called Q. Right? So we're doing just the simplest thing here. But it turns out that the plugin provides capability to allow you to specify things like which classes do you want to search across. You get to express declaratively in your domain classes which properties in those classes get searched. The way this is written right now, we're not specifying anything other than the search criteria. So when we execute a search, everything that's indexed is going to be searched. It turns out that the only thing that's indexed in our application is the real name property of person objects. But if we wanted to do more sophisticated searching stuff, we could do that. It just turns out that our application is doing only the most simple thing. Yeah. Yeah, so if in our status class, if we had a property that was searchable, which we don't, but if we did have, so if message was searchable here, that the way that our search form is written right now, we'd be searching for persons that have a real name that match Jeff, as well as statuses that have a message that match Jeff. The way that it's written right now, that's what would happen. Everything that's indexed is being searched. It just turns out the only thing we've indexed for this simple example is the real name property and person objects. All right, so back to our application. When I click search for users, we get a list of all the people that matched our search criteria. And I want to click follow here to express that Jeff wants to follow Graham. All right, so Jeff has posted two things. Jeff's going to post a third thing. And Jeff is following Graham right now. Rather than log out, I'm going to start up a different browser so I can have Jeff and Graham logged in concurrently. So this is Jeff back here. And over here, I'm going to log in as Graham. So in Firefox, we are Graham. All right, so Graham doesn't have any status messages posted. All right, I'm going to post Graham 1 and Graham 2. Right. The only things that show up down here are Graham's messages, not Jeff's messages, only Graham's messages. And if I go back here to Jeff's messages and refresh this page, we still don't see any Graham messages, even though I expressed that I wanted to follow Graham. Right? So let's look at the code, look and see what it would take to make that work. What I want to happen is if Jeff is following Graham, then Jeff's timeline will include Jeff's messages as well as Graham's messages. So let's take a look at that. So we talked about the followed property on line 12. Line 12 is expressing that every person has a set of other person objects that they're following. And if we go back to our status controller and look right here, this method right here, the follow method, is what got invoked when I searched for Graham and then clicked the follow link. This happened, and what that's doing is populating that set. I'm not going to I don't want to get distracted with that code right now, but what's happening when we invoke that follow method on line 28 is the Graham's person object is being added to the followed list for Jeff. Right? So the two are, Jeff now has another person object in that set called followed. If we go look at the status service, we'll see, I want the timeline service, not the status service. The timeline service is what's actually sending the query to the database to retrieve all the stuff that's going to be displayed at the bottom of the main page in the application. So get timeline for user is what's responsible for retrieving all the messages that are displayed at the bottom of that page. So what line 17 is doing there is retrieving a person object from the database. So username is going to be whoever the currently authenticated user is. So if I'm logged in as Jeff, username is going to be jbrown, right? That's going to retrieve the Jeff Brown object, the jbrown object from the database. And then I want to send another query to the database to retrieve all the messages that I want to display on Jeff's page. Status is our domain class. Remember that. Status is the thing that has an author and a date created and a message. We're invoking a method on the status class. We're invoking a static method on the status class called whereAny. And there is no whereAny method in our class, but somehow that'll work. And that somehow is Gorm will add a method called whereAny to all of your domain classes. And what you get to do with that method is you can invoke the method and pass a closure as an argument. And the closure is just a block of code here. So that closure is being passed as an argument to whereAny. And inside the closure, you can have almost arbitrary Groovy code. And the compiler, the Grails compiler, is going to evaluate all this code and turn that into database stuff, right? So you don't see anything there that looks like a SQL statement or anything that looks like that has anything to do with a database. But Grails is going to turn that into database stuff. What this says, so every status has an author, and every author has a username. So what this says is find all the status objects in the database that have an author whose username is equal to this. Right? So PER is going to be me. That's the currently authenticated user. So PER.username is jbrown. What line 19 is saying is this query should return all of the status messages posted by me. Right? But that's just Groovy code there. There's no database code, there's no SQL code, there's no HQL code. We're just writing Groovy code to express our criteria for our query. What line 20 says is if this person, if the currently authenticated user is following someone else, then include in the search results any status object whose author is in this list, per.followed. It's a set, it's not a list. So what this query should return is all of my messages and all the messages posted by folks that I follow. Right? Does that make sense? I want to order these results by date created descending. So I want the most recent, most recent at the top, and then they get older as you go down. And as time goes on, my Twitter timeline might have thousands or millions of status messages. I don't want to retrieve a million status messages from the database. So when I actually execute the query on line 22 there, what the list method will do is it will return all the objects that match this criteria. But I don't really want all of them. I want all of them with a max of 10. I don't want any more than 10 results to be returned from this query. And that's what line 22 is expressing here. I'm saying execute this query, send the SQL to the database, and return no more than 10 objects. So what this is going to return is a bunch of status objects, and those are going to be all of the status objects posted by me or by any of the people that I followed. They'll be sorted by date created in descending order, and we're only going to get the most recent 10. Right? And that's what's showing up at the bottom of the main page in our application. So let's start the application back up. Grails Twitter. Right? Any questions or comments about that query there? Yeah, very good. Being able to express your query in code instead of strings turns out to be a powerful and flexible thing that you'll take advantage of. I had 2 versions of the application running there, and I need to kill them. And by the way, so I'm doing all of this inside of the IDE. The IDE that I'm using is the Groovy and Grails tool suite. It's also called GGTS, which is built on top of Eclipse. So it's Eclipse with a whole bunch of special Spring and Groovy tooling installed into it. GGTS is free. If you're going to do Grails development, GGTS is a fantastic environment to do that. Yeah, so the server is doing the query, right? You can't execute the query in the browser. The data is not in the browser. Yeah, so the question is that closure executing is the query being sent to the database, we get back all the objects and then filter them by executing this closure? Is that what you're asking? And that's not what happened. If that is what happened, that would be almost unusable. That'd be bad. A whole bunch of really sophisticated, cool stuff is happening at compile time to turn that into the necessary code to send a query to the database, and that query includes a where clause that expresses all the stuff that's described in your code there. So it would be really bad if what that did was retrieved every status object from the database and then filtered them. There would be no reason to have such a feature, but that's not what's happening. Yeah. Does that make sense?
Yeah.
Yep. All right, Jeff 1, I'm going to post a couple of messages here. Jeff 1 and Jeff 2. Right, so there's my timeline, Jeff 1 and Jeff 2. We'll go over here and log back in as Graham in a different browser, so we'll have a different session and so forth. Graham. And we'll say Graham 1 and Graham 2. All right, so now Jeff and Graham each have a couple of messages posted on their timelines. They're not seeing each other's messages, but over here as Jeff, I'm going to search for Graham and I'm going to express that I want to follow him. And now we're seeing Graham's messages on my timeline, which is what we wanted. We'll say Jeff 3 and Jeff 4. And I'll introduce a problem now. So right now, things look okay. I'm seeing all of my messages, and I'm seeing all the messages of the people that I follow. Right? Graham's the only person that I follow right now. We go over here, and Graham posts another message, Graham 3. If I come back here and refresh this page, we don't. I just refreshed that page. We don't see Graham 3. So let's figure out what's going on there, and that's going to allow us to add one more feature to our application, which is what we've got time for. Just one more thing. So the problem, what's happening is this get timeline for user method is being cached, right? We're using a cacheable plugin. The cacheable plugin is really cool stuff. We could spend a long time talking about that, and we just don't have time to get into it. Just know that by putting this annotation on this method, I'm taking advantage of some really sophisticated caching stuff offered by the cacheable plugin. So now every time I retrieve my timeline, we're not necessarily going to the database. We might be retrieving that stuff from a cache, which is good. All right, so get timeline for user is cached. So I retrieve all my messages, and they're put in the cache, and they're rendered on the page. When I update a message, when I post a new message, one of the things that happens is, if we look at our timeline service, where is our, oh, it's the status service we want. One of the things that happens each time I update a status, this is the code that creates the new status, is line 29 is invoking a method called clear timeline cache for user. And what clear timeline cache for user is doing is emptying my timeline cache, right? So I've got a bunch of statuses in the database. I retrieve them, they go in the cache, they get rendered on the page. The next time I retrieve them, they're already in the cache, so we don't have to go back to the database. But if I post a new message to the system, I need to clear that cache, right? I don't want to get the cache doesn't have the new message. So the code we just looked at makes that happen. We need something else that will do the same thing when one of the people that I follow posts a message, right? The reason we're not seeing Graham's message in the browser right now is my cache is out of date. I can refresh this all day and Graham's message will never show up. Notice we do not see Graham 3 here, but as soon as I post another message of my own, Graham 3 showed up, right? Because when I posted my own message, my cache was cleared, so the next time I retrieved the timeline, we got not only my new message, but we got the message that Graham had posted. So the problem is that when I post a message, my cache is being cleared properly, but when someone else posts a message that I follow, my cache is now stale. That's no good. We can't, so we need to clear the cache when one of the people that I follow posts a message. But now we're starting to wander into stuff that could potentially take a long time, right? If I'm following 1,000 people, when one of those people posts a request, everyone that they follow needs to have their caches cleared. That could take a long time. So now you don't want to do that in line as part of that request processing, right? When Graham posts a message, we want to get a response to him as quickly as possible. What we don't want to happen is for Graham to post a new message, and then we're going to spend 1.5 seconds clearing out everybody's cache who follows Graham, right? That's not good. We need to clear all their caches, but we don't want to do that in line there. We want to get a response back to him right away. So we can do that asynchronously, right? We can do the status clear, the cache clearing sort of out of band, right? So Graham posts a message, we put his message in the database, we send an asynchronous message to go clear all those caches of people who follow Graham, but then immediately get him a response and then somehow process those clear the cache requests later. And the code to make that happen can be as little as something like this. So in my status class, I've just added a couple of things. I've declared a property called JMS service. We've got a plugin installed into my application that is the JMS plugin, and the JMS plugin provides a service called JMS service, and the JMS service does a bunch of stuff, and we're going to look at just one thing that service might be able to do for us. So that thing, that reference that's declared on line 10 will automatically be initialized by Grails for the same reason the other service we talked about earlier was initialized. So this is going to be an instance of some class provided by the JMS plugin. And what line 12 here says is post a JMS message to this queue, right? Grails Twitter.status, and this is the value of the message. So we're putting a message on a JMS queue, and the value of the message is simply my username. It's whoever just posted this message, right? And if we go look at our status service, we'll see that the status service expresses that it wants to expose itself using JMS, and that's what line 10 does. It turns out that we don't have to know very much at all about JMS to put all this together. There's really no JMS code here, but we're taking advantage of a lot of sophisticated, powerful stuff that JMS has to offer. But the JMS plugin is taking care of all the complicated stuff. What I have to do as an application developer is write a service and express that I want to expose it using JMS, which is what I'm doing on line 10 there. And there's a way that you can configure the plugin so you can call this method whatever you like, but by default, the method has to be called onMessage. And that's the way that the plugin will notify this JMS listener of new messages. So every time a message is posted to the status queue, this listener is automatically going to be notified. We don't have to. We've seen all the JMS code we have to write to make that happen, but we're taking advantage of a really powerful JMS engine. So what this code is doing, every time this method gets invoked, what we're doing is we're sending a query to the database to retrieve all the people that follow username, right? New message username is the name of whoever just posted a message. We want to go find everyone who follows that person and then clear all of their timelines, which is what's happening on the next couple of lines there. But this is happening out of band, right? This is not part of any request, right? A request came in with a new message. We created a new status object, put it in the database, put a request on a JMS queue to do some work, and then carry it on and finish the request. And then at some point, the JMS queue processing will happen. This code gets executed, and now the server's out there clearing all these timelines that need to be, all these caches that need to be cleared. But if this takes a second, we're not tying up that request for a second. Right? We're taking advantage of the asynchronous messaging offered by JMS. But we didn't have to write really any JMS code. We wrote a service and expressed on line 10 that I want this service to be exposed via JMS. And then over here, this is the end that produces the message. I'm taking advantage of this JMS service provided by the JMS plugin. And you have to read the documentation and know how to interact with that thing. But what we're doing is we're calling send and passing two pieces of data. The first is the queue name. The second is the message. So we really didn't write any JMS code, but as I've said several times, we're taking advantage of what JMS has to offer there, right? So we've seen, obviously I've had to go through all this really, really quickly, but we're taking advantage of some pretty sophisticated stuff. We're taking advantage of JMS, we're taking advantage of some really sophisticated stuff provided by the searchable plugin. We've got the whole Hibernate abstraction. There's a lot of really, really cool stuff going on in our application, a lot of powerful and sometimes complicated stuff going on in our application, but all that complexity is being managed for us by the framework or plugins in different situations, right? So the Grails application code stays very, very simple, right? So as I said, obviously I know that I went through all that really, really quickly. The idea is just to provide a sense for the kinds of things that the framework helps make simple in your application. So any questions or comments about any of that? We've got about 2 minutes, and then I'm happy to talk to you as long as you like, but any questions right now? None? All right, very good. thank you all very much. If there's anything at all that I can help you with, let me know. As I said, my email address is jbrown@gopivotal.com. Twitter is Jeff Scott Brown. And thank you very much, and enjoy the rest of the show.